At first glance, it looks like a mistake, a narrow strip of asphalt trapped between towering Himalayan peaks. A runway surrounded by cliffs, unpredictable winds, and mountains rising thousands of meters into the sky. For most of human history, this was a place where people believed aircraft simply did not belong. Because airports are supposed to be built on open land, flat ground, predictable weather, plenty of space. But in the tiny Himalayan kingdom of Bhutan, engineers faced a completely different reality. They were asked to build an international airport in one of the most dangerous aviation environments on Earth. Not on a wide plain, not beside a city, but inside a deep mountain valley of more than 2,200 meters above sea level, where pilots must navigate between peaks, where clouds can appear without warning, and where even a small mistake can have serious consequences. This is Paro International Airport, a place so extreme that only a small number of pilots in the world are qualified to land there. But the most surprising part is not that planes can land here. The most surprising part is how this airport became possible in the first place. Because before there was a runway, before there was a terminal, before there were aircraft crossing the Himalayas, there was only a valley surrounded by some of the most challenging terrain on the planet. And transforming that landscape into a functioning international airport required engineers to solve a problem that seemed almost impossible. How do you build modern aviation infrastructure in a place where nature itself appears designed to stop you? The answer begins deep inside the geography of Bhutan. Hidden between India and Tibet, Bhutan is a country dominated by mountains. More than 70% of its land is covered by forests, and the Himalayan terrain controls almost every aspect of life. For centuries, these mountains protected Bhutan from outside influence. But they also created enormous challenges that travel between communities was slow. Roads were difficult to build. Large flat areas were extremely rare, in many parts of the country. Reaching another region could take days, so when Bhutan began looking for a way to connect itself with the rest of the world, aviation became one of the only realistic solutions. But aviation in Bhutan came with a problem. The mountains that made an airport necessary were the same mountains that made building one incredibly dangerous. The chosen location was the Paro Valley, a beautiful region surrounded by dramatic Himalayan peaks. Ancient forests and historic landmarks to ordinary eyes. It looked like the perfect place for a scenic airport to engineers. It looked like a nightmare an airport runway needs precise conditions. IT must be long enough for aircraft to accelerate and stop safely. IT must have stable foundations. IT needs reliable navigation systems. IT requires space for terminals, maintenance facilities, fuel operations, emergency services, and access roads. But Paro offered almost none of these advantages. The valley was narrow. The surrounding mountains created complex wind patterns. The elevation reduced aircraft performance. And unlike a normal airport where pilots can approach from miles away over flat terrain, Paro required aircraft to enter through a mountain corridor with limited visibility. The airport was not just a construction challenge. IT was a human skill challenge. Before any concrete was poured, engineers had to understand a mountain environment itself. They studied the valley like a living system. They analyzed the shape of the terrain, seasonal weather patterns, rainfall, river movement, soil stability, and wind behavior. Because in the Himalayas, the ground is never just ground. A mountain slope contains hidden forces. Water moves beneath the surface. Rock layers shift over time. Heavy rainfall can trigger erosion. Thus, small mistake in planning could create long-term instability. The first challenge was finding enough space that a traditional airport spreads across a large flat area. Paro had a valley floor surrounded by mountains. SO engineers had to carefully use the limited land available. The runway alignment had to follow the geography instead of fighting against it. Every angle mattered. Every meter mattered. The airport could not simply be placed wherever engineers wanted. The mountain decided the rules. And this is where the project became different from almost every other airport in the world. Instead of conquering the landscape completely, engineers had to work with it. The runway, terminal, and supporting infrastructure had to fit into the environment like a carefully designed puzzle. But designing the airport was only the beginning. The real challenge of construction, because bringing heavy machinery into a remote Himalayan valley was itself a massive operation. Large airports are usually built near major cities where equipment, materials, and workers can move easily. Paro was different. Every machine, every piece of material, and every construction resource had to reach a difficult mountain location. Road access was limited. The terrain was challenging. Weather could interrupt work for long periods. Construction teams had to operate in an environment where nature could change the conditions overnight. The mountain was not a passive construction site. The IT was an active opponent. Workers faced steep terrain, heavy rainfall, cold temperatures, and the constant challenge of maintaining stability. Before the runway could exist, the ground had to be prepared. The valley surface had to be strengthened and shaped. Uneven terrain had to be carefully modified. Drainage systems had to be created because water is one of the greatest enemies of mountain infrastructure. A runway might look like a simple flat surface, but underneath it is an engineered structure designed to carry thousands of tons of force. Every layer has a purpose. The foundation must support repeated aircraft movements. The surface must handle weather changes. The drainage must prevent water from weakening the structure. Because at high altitude, failure is not just inconvenient. IT can shut down an entire airport. And then came one of the most difficult parts of the project, creating an airport runway that could operate safely in thin mountain air. At 2,200 meters above sea level, aircraft behave differently. The air is less dense. That means aircraft engines produce less power. Wings generate less lift. Takeoff and landing calculations become much more sensitive to a runway that works perfectly at sea level may not provide the same performance in the Himalayas. Engineers had to account for these conditions from the beginning. The runway had to be designed with aviation physics in mind. But even a perfectly built runway would not solve the biggest challenge. The mountains themselves that a pilot approaching Paro does not simply follow a straight path toward a runway. The surrounding peaks make a normal landing approach impossible. Instead, pilots must follow a highly specialized route through the valley. They navigate between mountains, making carefully calculated turns while maintaining control of the aircraft. This is why Paro became famous among pilots. Landing here requires exceptional skill. Only specially trained pilots are allowed to perform these approaches. The airport does not rely only on technology. IT depends heavily on human experience. The pilot who operates here must understand the terrain, the weather, the aircraft, and the behavior of the valley itself. But even after solving the aviation challenge, engineers still had another major problem. An airport is not only a runway, IT is an entire ecosystem. Passengers need terminals. Aircraft need support systems. Workers need roads. Emergency teams need access. Fuel needs. Storage. Communication systems need protection. Everything must function in a location where repairs and maintenance are far more difficult than at ordinary airports. The terminal building had to become more than just a passenger facility. IT had to survive the Himalayan environment. Strong winds, temperature changes, heavy rain, and seasonal conditions all influence its design. Inside, passengers would eventually experience something unusual, that a modern airport surrounded by some of the most dramatic scenery on Earth, at a place where travelers could look outside the terminal windows and see mountains rising around them. But behind that beautiful view was a complex engineering system, electrical networks, security systems, baggage handling, communication equipment, emergency infrastructure. Every part had to be carefully planned because there was no easy backup option. If something failed, the mountains made every solution harder. And then came another hidden challenge that many people never notice: keeping the airport connected to the outside world. Aviation cannot exist without transportation networks. Passengers, employees, supplies, and emergency vehicles all need reliable access, as the airport requires supporting infrastructure around it: road improvements, bridges, mountain routes, drainage protection, safety barriers. Every connection had to be designed for a difficult environment. The airport was not simply placed inside the Himalayas. The entire surrounding area had to adapt around it. But even after construction, testing, and preparation, the final question remained: could aircraft actually operate safely here? Could this idea that seemed impossible become a real working airport? The answer would come from the sky. And the first aircraft approaching Paro would reveal whether years of planning, engineering, and human effort had truly defeated the Himalayan challenge. Because building the airport was only half the battle. Making it work would become one of the most fascinating aviation stories in the world. When the first aircraft finally approached Paro Valley, it was not just another landing. IT was a test of everything. Years of planning, thousands of engineering decisions. Countless hours of construction to a single aircraft would reveal whether humanity had successfully created a gateway to one of the most difficult landscapes on Earth. The aircraft descended toward the valley, surrounded by towering Himalayan peaks. There was no endless runway view stretching toward the horizon and wide open landscape. Only mountains, air currents, and a narrow path carefully designed to precision. The pilot followed the approach route, making controlled movements through the valley. Every calculation mattered. Every second mattered. And when the wheels touched the runway, the impossible became reality. An airport had been created in a place where nature seemed to reject the idea completely. But Paro Airport was never only about concrete, asphalt, and aircraft. Its existence changed. The relationship between Bhutan and the rest of the world. Before aviation, Bhutan's geography created isolation. The mountains protected the country, but they also limited connection to a journey that required long and difficult travel, could now be completed in a fraction of time. The airport became a bridge between Bhutan and the outside world, the bridge built not across a river, but across one of the greatest natural barriers on Earth. However, the real importance of Paro Airport goes beyond. Transportation, IT changed tourism. Bhutan had always been known for its unique culture, ancient monasteries, untouched landscapes, and Himalayan beauty. But reaching the country was difficult. The airport opened a new possibility. Visitors from around the world could now experience Bhutan directly. The valley that once represented isolation became an international arrival point. Hotels developed. Local businesses expanded. Tourism became a stronger part of the economy. But the airport also carried strategic importance. For a mountainous country, aviation is not just about convenience. IT is about emergency access, medical transportation, disaster response, connecting remote communities. When roads are damaged by landslides or extreme weather, air connections become even more valuable. A single runway in a remote valley can become a lifeline. Yet building Paro Airport also revealed something important about extreme engineering. The greatest challenges are not always solved by using the biggest machines or the most advanced technology. Sometimes they are solved by understanding the environment. Engineers could not remove the Himalayas. They could not change the mountains into a flat plain. They had to study the terrain, respect its limitations, and create a solution that worked within those boundaries. This philosophy is becoming increasingly important around the world. As populations grow and available land becomes limited, engineers are being forced to build in places once considered impossible. Across the planet, humans are creating infrastructure in deserts, oceans, frozen regions, and mountains. But every extreme project carries the same lesson. The environment always has a final word. A structure may be impressive, but if it ignores nature, it will eventually fail. Paro Airport continues to operate because it was designed around the mountain, not against it. The airport's biggest engineering achievement is not that it defeated the Himalaya. IT is that it found a way to cooperate with them. But even today, landing at Paro remains one of aviation's most challenging experiences. The surrounding mountains still stand exactly where they always have. The weather still changes quickly. The valley still demands respect. Technology has improved, but the human element remains essential. Pilots must still rely on training, judgment, and experience. Because in this environment, computers and instruments cannot completely replace understanding. The mountain itself becomes part of the flight. Every approach is a conversation between the aircraft and the landscape, and this is what makes Paro different from almost any other airport on Earth. That IT is not simply a place where planes arrive. IT is a place where engineering, geography, and human courage meet. The runway represents more than a transportation surface. IT represents thousands of decisions made under uncertainty. Every layer beneath the pavement carries a story. Every support structure reflects a problem that had to be solved. Every aircraft that lands or proves that a seemingly impossible idea became reality. But perhaps the most fascinating part is what this project teaches about the future. As cities expand and natural landscapes become more challenging, engineers will continue searching for new ways to build where construction once seemed impossible. Future airports may rise above water. Transportation systems may cross extreme environments. Mega projects may appear in places that today seem unreachable. And the lessons learned from places like Paro will influence how those projects are designed. Because the future of engineering is not simply about building bigger. IT is about building smarter. IT is about creating structures that survive because they understand the world around them. Paro Airport began as a question. Can an international airport exist in the middle of the Himalayas? The answer was hidden behind years of uncertainty, engineering challenges, and human determination. The mountains created every obstacle. The altitude reduced a margin for error. The geography demanded innovation. But step by step, engineers transformed a difficult valley into one of the most unique airports on Earth, a place where passengers do not simply arrive at a destination. They enter through a landscape that looks almost unreal, a place where the runway appears to float between mountains, at a place where every landing feels like a reminder of what humans can achieve when imagination meets engineering. Because sometimes the most incredible structures are not built in the easiest places. They are built in places where the world says they should not exist. And Paro Airport is proof that even among the highest mountains on Earth, human creativity can find a way forward.